Okay. Let's see. Audio capture. Mm. For passkey. Um, what is the fuse? Okay. Confirm. Yes, it's me. Okay. So you are given a integer array prices. This is the price of price as the price of Neetcode and I day. You may choose a single day. Okay, so buy on the second day. Okay, so it's a sliding window problem. Okay, so if I buy on price at 10, can it get any better if I move the expanded the window. Hmm. But what if there was like 30 here? You're buying high and you're selling low. Okay, so we can slide the left part of a window. If the or I guess you could reset, right? So you can reset the left edge of the window to index 1 um when the left edge is greater than the right edge. Um so I slid it over, or reset here, and then expand the window. So 5 is um less than 1. So we expand. Um, we're constantly updating, and then we get to 1. Okay. Uh, so if we have 10, okay, max profit, prof, I'll just say res equals 0. And then what we can do is um, if length res equal to 1, or prices equal to 1, so they return 0. Okay, now here, um, I is equal to 0, while less than length, prices minus 1. What we can do is we can ask the question, well, if prices I, no, j is equal to I plus 1, um, if prices I is less than prices j, we can do a calculation, right? So we can res is equal to max res prices j minus prices I, right? Um, LF prices. We can just do else. J. While J less than length prices and prices I. So J less than length prices. J plus equals 1. So we're trying to expand our window. Um, mm, I can do this. If prices I is greater than prices J, I is equal to J, continue, right? Um, here, then we can reset I is equal to J. Mm, okay, res. So actually, I think I like this better. While I is listening. Do you even need this check though? I don't think you need this. Max, I think this will work. Yeah. What? I'm gonna expand the window though. It's time to buy and sell stuff. Hmm. Let's copy this. It's slow. Is this a, this is a valid solution though? I mean, it runs in ON. Hmm. What does the solution look like? For should feel comfortable arrays. Minimum buying price for global optimization. Um, okay, that's like n squared, bro. That's n squared. Don't want that. Mm. I want to buy at a low price and sell at a higher price. Buy at a low price and sell at a higher, that comes after using two pointers. If the right price is higher than at L, we can make a profit. So we update the maximum. If the price at right is lower than then R becomes the new L because a cheaper buying price is always better. If R is lower, then R becomes a new L because the cheaper buying price is always better. Oh, this is pretty much what I this is pretty much what I did, right? Hmm. Clean. Would you consider this a would you consider this window or two pointers or is it both? Pretty sure it's both. Okay, so it's more 2 pointers. It feels like a sliding window though. Hmm, I don't need that. Okay. What's the actual roadmap? The like the roadmap. Tracking DP, okay. Okay, so we're gonna solve longest substring without repeating characters. Okay, so given a string S, find the length of the longest substring without duplicate characters. Okay. Um, mm, okay, duplicate detection. Hmm. Start our window at 1. We expand, and we expand. Okay, so we go at, um, we iterate the string, and, or at index 0, um, this is the first time seeing Z, so um, we move on to the next character. First time seeing X, so we move on to the next character. And then first time seeing Y, we move on, and we see Z again. So when we see Z again, um, what would be helpful to know is not only not only what is it we don't want to just know that Z exists, but we also want to know um where, right? Because then if we know where the last Z existed, we can move our pointer, or we can slide our window, shrink our window from the left, um, past that index, right? And at this point, we will have a non-duplicate substring. Mm, and then we can update um, our length, our substring length. Um, and then here we can again start expanding again. So okay. So we can say res equals um, actually we can do something similar. So if length s is equal to 1, simply return 1. right? That's like a base. Find s is equal to 1, return less than equal to 1, return like s. Um, okay, so we can say, I think it's fine to set rest 1, and then LR 0 comma length s. No, you can do this, and then what we can have is a, I'm pretty sure you can use a hash map here. Okay, so hash map is equal to, okay, then um, SL, you want to map that to 0, comma, SR, I want to map that to 1. Is this valid? Is this a valid way to initialize? Wise in Python dictionary. Okay. Okay, so we have this, right? Then while r less than length s, um, what we can do is say wait. Should I initialize this? I should just initialize it with the first, right? Okay, so if SR and hash map, what we want to do is index is equal to map SR, right? And L is equal to index, R is equal to L plus 1, index plus 1, um, Okay. Now, do we update R though? No, we don't want to update this. We just want to update L. Index plus 1, right? And then we can just do res is equal to max res. Um, well, you shrunk it, so you don't really need to update the H map SR is equal to R, right? We want to update this. Else, sign there. So we just do uh, res is equal to max res r minus L plus 1. What's that? If we have if we have 5 elements, so it'd be 0 to 4, 4 minus 0, 4. Okay, yeah, so R plus 1. Turn res. I think this should work. No? Hmm. Okay, we have Z, X, Y. Oh, hmm. I can do, let's see, print R minus L plus 1. Wait, R minus L plus 1 plus 1. Let's see. So it's 2, 3. Index is equal to H map SR, which would give you this. How is it getting the 5 though? That's what I don't understand. ZXY. 3, and then here Um, hmm. Am I tripping? Why does why does so we have let's see. Hmm. Okay, let's try to z x y z x y z, right? So we have hash map. So z points to 1, then r was set to 1. Oh, I think you can do this, right? If SR is in here, okay. If we have AB, AB, how's it getting 3? A, B, and then B. So it would be 1. Wait, L would become 0, 1, 2, right? How is it getting 3 though? Let's see. Int R minus L plus 1, 2, 1, 3. Expected is 2. R minus L 2. So one iteration, wait, two, and then how is it getting three though? 0, 1, 2, 2, 1. How is it? Maybe I could do this, bro. Else, no. Hmm. The quick brown fox jumps over the lazy dog. The quick brown fox jumps over. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17. Mhm. Why are they getting 16 though? Hmm. Not understanding how this is getting 16 though. How though? Hmm. Okay, so it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. No. SR in Edgemont? Oh, mm, curious, why is this not but we want to check still, right? Like even if we updated our left index, okay. Maybe you need to rerun this again. No, that's absolutely not the case. Why am I getting... That's my question. The quick brown fox. But this should already 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17. EHEQU. Oh shit. Oh, okay. O is the first. 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. Console log y minus plus 1. Oh, I'm writing JavaScript. Print. All right, it stops at 14. And then what does it go back down to? 5. Hmm. Yeah. 6. What? Goes down to 5 and then it goes to 6. 6. Oh, I see. So when you jump, okay, so basically when you jump, when you reset the left bound, um, and H map SR greater than L. We want to know, we want it to be and H map SR is greater than L. That's when we do the resetting. No, greater than or equal to. Okay, Gucci. See. So when we have 2, 3, then why are we getting 4? Okay, yeah, because we want to consider that too. All right, bet. Let's see how fast this runs on Neetcode. Longest substring. Wait, longest substring. Is a medium question? Length of longest substring. Okay, this is the problem. Let's try it. Should work, right? Okay, it should work. All right, that's the end of the stream.